Good morning, good afternoon, and good evening, all of 721 students. This is going to help you, hopefully. Mr. Matt here, making a video for your physics distance learning and the CE program. Now, let's look at first where we can find our workbook 2, because this video will go through the workbook 2. Basically, if you're struggling, you don't understand something, you can watch this video to help you complete the activities to be ready for any assessments. So we are in the shared folder like always. We need to go to our physics folder, and quarter 3 now. Workbook 2, WB2, there it is. Let's just click on that. Just check it looks like physics. Yeah, that's the one. So if you have an iPad, you can do it the usual way, using Notability and fill it in. If not, I will show you a method I'm using because I don't have an iPad. I have a laptop, so I'll just download it from Google Drive. Google Drive is all online, so everything here, all you need is to be online with your phone or your laptop, which I'm sure everybody is. Okay, I've downloaded it, so it's down there. Now I go to another website called PDF Escape. So PDF Escape. Now, if you have Notability and iPads and apps and things, and you have a way to write on the PDF, that's fine. Use your way, but this is my way, and it just needs PDF Escape. pdfescape.com.com. So just type that into your search bar and you will see there's a free version. I will use that. It's all online. You don't need any software. It's simple. Just upload. You want to go and upload, and then find the file wherever it is when you downloaded it from Google Drive, and just drag it into here. Okay, like I said, if you have Notability iPads, use your method. This is my online method for editing PDFs, and you can see now you can use all the similar things to Notability. Notability is better, so if you can, use that, because you can draw better lines and things, which is useful for this. So let's just check it's the correct workbook. Workbook 2, level 2, quarter 3. Yeah, that looks the same. Check it's all there. Yeah, this is the same one. And now you can just go about using the tools up on the left here. I can type in whatever I want here. Mr. Matt is the teacher, but that's a bit small, so you can change the size of the writing too. Let's go to 18. That's a good size. Fill it all in. Fill it all in. Should have done this already, really. You know what you're doing. With the signature, you can use freehand, and so you can swap between the two easily. Don't forget the date. Now, these are the key terms, or some of the key terms. The Arabic translation is always like this in physics workbooks, so that's nice for you. And some explanation too. I won't go through these now because as we go through these next few weeks, they will become clear. So they're all there at the top. If there is a word you forgot the meaning, just go back to it and check the Arabic and go, ah, yeah, maybe you remember with some help. Okay, let's look straight into the first 2 lessons then. Now this video will cover 4 lessons, so it's gonna have focus. 4 lessons of learning in this video. So the first question is, why a long stick appears to be broken if it's placed in a swimming pool? Now, let's go through this together. How much space to write here? It's to do with this word here. It's called refraction. Refraction. And it's because when light, look at this picture here. When light, here's some light. This red arrow is my light ray. We've drawn these before. But when the light goes in and when it hits the surface of the swimming pool, it changes direction. Notice it's not in the same direction as before. If I draw a straight line, like this pencil, it would be like this, but it's not. It's changed direction. When it hits the water here, it actually goes further down, or what we say, towards this dotted line here. It gets closer to the dotted line. And that dotted line is called the normal line. So we ask ourselves the question, why a long stick appears broken if it's placed in a swimming pool? Now I'll show you an example of this now. I have some water here. And you can see that as the light travels through the water, it's changing what things look like. The water, the light is changing direction, it's bending. It's making things look different. I'm just going to put this is, I hope you agree, this pencil is a straight pencil. It's not a magic pencil. This is just a glass of water. Now if I put this pencil in like this, you can see, let's get it, that the water and the pencil is the same, but it looks like the pencil is broken. Why does the pencil look broken? That's the question, basically. I can take it out again. It's not broken, so it's kind of like a magic trick, but it's not. It's just physics. It's just physics because the light changes direction, so it looks like the pencil is in a different place. So, in a very short answer, we could write here, because we don't have space. So why is it broken? Because when light travels into a new, now we call something that is different, like from an air to water, we say air and water and solids, they are all mediums. That's a new word for you there. You can think of medium usually as like large, medium, small. Medium is in the middle, but in physics we can say medium is like a solid or a liquid or a gas, or even different liquids too. So you could have oil or water, they are different mediums too. So like materials, kind of similar. So different material, different medium, when it travels into that new medium, it changes direction. So the object doesn't change direction, only the light. And when we see that light, it looks like the pencil or the stick in this question is in a different place. That's a very simple explanation there. And we have to know how it changes direction, so we have to describe more than just this, but that's a good start point. And how do we describe it? Well, we have to say if it's going towards the normal or away from the normal, the light. And the light here is bending, changing direction towards the normal. What am I talking about, the normal, you ask? This is the normal, right? This imaginary line, this line is not real. It's our normal line. We always draw it on a diagram, a picture like this. And we draw it just where it hits the surface. So the light is coming in, it hits here, and we draw the normal line where it hits. And we draw it always at 90 degrees to the, let me draw that, 90 degrees, can't see that very well, can you? 90 degrees to the surface. We call the surface the boundary. Okay, I'll just put my little degree sign in there. So that's always 90 degrees. It's not a real line. Like I said, the boundary is a real line. You can see the surface of the water, but at 90 degrees, we just draw this line, this dot line, and then it helps us to solve problems like the ones we will look at today. And we can see here that the light is bending slightly towards, closer to this line. If it bent even more, maybe it goes like this. And as we bend it, you can see if it goes towards this line, closer to the line, or further away. If I drew the line straight, so it's a little bit closer than before. So if we're going into a more dense, optically dense medium where there's more particles, for example, we will go towards the line, the normal line. The opposite is true if we go the other way. That's this diagram explains normal line, boundary line. We have two different mediums. Here we call them substances. And we have the light coming in. It hits the boundary. It changes direction and it carries on. Always in a straight line, but changing direction here. There are two important angles we can understand as well. This angle, as the ray comes in, this angle here is called the angle of incidence. And it's the angle between the ray coming in, the incidence ray, so it's the angle of incidence, and the normal line, this angle. And when the ray changes direction, if a ray changes direction, we call it refraction in this case. So the angle between these two lines is called the angle of refraction. That's lots of definitions in this diagram, one to learn for sure. Let this load. We've talked about these things a little bit already. Let's go to task 1. Actually, I'd rather do task 2 first because it explains things better. Now, if we go from air to glass and then to air again, we are going into a more dense medium. So we have to think about what happens with the ray. Well, it will go towards the normal. If we think the normal line is here, if I can draw easily a line using this software. It won't be perfect, but we'll do our best. So if I draw the normal line, so this is just an imaginary line where it hits. It's not very good because it should be right next to this arrow, but it's close. And then when it hits, it will travel the actual ray. No, that's no good. Well, we'll do our best. The ray, it should be a straight line. If you have an iPad, you can do it very easily. So light always travels in a straight line, it just changes direction. But you can see there that the light has changed direction a little bit, because if it's a straight line still, if it carries on, it would go this way. But I moved it towards the normal line, because that's what happens when you go into glass. A more dense medium where there's more particles, more optically dense we call it. Now let's go back out into air. Well, guess what happens in air? The opposite happens, because there's less optically dense medium here. So we will draw it going back away. Let's go to freehand. This should be a straight line. I know it's not. So it goes towards the medium and then goes back away from the medium boundary again. When I say medium boundary, I actually mean a normal line. So let's draw it in. So you draw a normal line at every boundary. So here's my two boundaries. And I can see the light traveling towards the normal, closer to the normal line. And then if it went towards it again, maybe I could draw the arrow here even, because it's almost so close to the normal line that it's on, but it doesn't travel when it goes away from the glass back into the air. This boundary, this surface, the opposite happens because it's going back into air again. It's a less optical.